I'm going to describe how to use an interactive simulation that allows you to compare reactor configurations and to change relative volumes of reactors. So the idea is you have two reactors in series. In this case, for the figure I'm showing here, it's a plug flow reactor followed by a CSTR. The idea in the simulation, you can change the order of the reaction up here. You can change the reactor types. You can have two CSTRs in series, for example. And then you can change the conversion that leaves the first reactor. This is 0.63. And then the conversion from the second reactor, 0.84. And what we're plotting here is the molar flow rate of the reactant A entering the reactor divided by the rate of reaction of A with a minus sign to make the term positive. So the area, in this case the orange area and the green area, is proportional to the reactor volume. And so the simulation then allows you to change how big a plug flow reactor, how big a CSTR, get an idea of how we could minimize the reactor volume for different reaction orders. So let's look at the simulation, which is located in the Wolfram site, and I've given here in blue at the top the location of this simulation. So here's the interactive simulation showing for a first order reaction. We have a CSTR, so CSTR is in yellow, followed by a plug flow reactor in orange. And if I increase the conversion for the first reactor to CSTR, notice the total volume, in this case 1.4, had increased. I go to make the CSTR smaller and the plug flow reactor, the second reactor, bigger, my total reactor volume goes down. I could also compare in the reverse order. Well, now as I increase the size of the first reactor, the plug flow, I'm going to decrease the volume, right? The volume is proportional to some of these two areas. I can compare for second order, where it's more extreme in terms of, now the volume of a CSTR to get to this high conversion is really quite large. This also allows us to look at Langmuir-Hinshelwood kinetics, which are different behavior, different shape of the curve, such that now we can compare CSTR followed by a plug flow reactor, and making a CSTR bigger, as you can see, decreases the total volume. So you can use this to get a better physical understanding of behavior of reactors in series and effects of the concentration in the reactor on the rate of reaction.